Hello, we continue to look at example word problems regarding with the use of proportions and scaling up or scaling down ratios. Let's take a look at the problem number 3. We are on page 116. Sandy makes a map of a pool area. She uses 1 centimeter to represent 250 centimeters in the real world. Here it is. Here is this important information about the map. I'm sure you've seen different maps that always in the legend somewhere in the corner, in the bottom, talk about the scale and proportion of the map to the real world. So we can write down what is given. That's very important information that you identify in the word problem. First question you have to ask yourself, what is given? And we know that map to reality is 1 to 250 centimeters. And of course, both are 250 centimeters. That is your key ratio given at the start of the problem. Now, the second question you have to ask yourself, what are they asking us to find? So the question is on the map, here it is, on the map, this is A and the middle cell B. The length of a pool is 15 centimeters. Here it is. The length of a pool is 15 centimeters. Find the actual length. So find the reality, right? Maybe I can write it here. Actual distance. So what do we have? We have map to reality is 1 to 250. That is the key given ratio. Now, if on the map the length of the pool is 15 centimeters, that's another thing that's given, we need to solve for the actual length of the pool. And I'm going to put it in as an x. Let's solve this proportion, my friends. Again, we are seeing a proportion. As I mentioned in my previous video, proportion is 2 ratios tied together, and those ratios are related. And if you have 4 data points, if you're missing 1 data point out of the 4, you can always find for the missing quantity. You can always solve for missing quantity. Let's go ahead and do this. And then, of course, I will show you how they're trying to show us in the solution. So we can say that 1 to 15 on the map has to be proportionate to 250 to x. Notice how I am comparing map to map and actual length to actual length. Now, how do we solve this particular, we have related fractions, right? How do we solve this? I teach my students the butterfly method. And the butterfly method, or cross multiplication of proportion, we will learn early next year in our algebra class, but you multiply diagonally what is a cross, and I'm going to put multiplication. You, out of the 4 corners of the proportion, you multiply diagonally what is a cross and divide by the third quantity. So let's write it down. We would say x equals 15 times 250 and divide by 1. And 15 times 250 is, we have to do the math. Miss Natasha has to do the math. 25 times 15. So we have 5, 2, 125, which I should have known, plus 25 is 5, 7, and of course we have a 0. So we have a 0 right here. So the answer is 3,750 centimeters long. That is the length of the pool. So another way, which we've seen in the previous example, another way, I'm going to delete my calculation here to free up some space. Another way to structure this proportion is that you could have structured it in this direction. Or you could have structured it like this. You could have done top to bottom, or bottom to top. You can say 15 to 1 has to be in proportion, as x to 250. No matter which way you try to set up your proportion, as long as you stay consistent, the solution will be the same. Multiply diagonally what's across, divide by the third quantity. And the solution is x equals 15 times 250, divide by 1. So here it is, 250 times 15, and the answer is 3,750 centimeters. The actual length of the pool, notice they're asking for meters, it's 3.75 meters. That's in reality, in real life. Let's take a look at problem B. Now, what is given? The distance between two lamp posts, right, on the map. Here it is. The distance between two lamp posts, right here. The distance between two lamp posts is 12.5 meters. It's 12.5 meters, right? Now that's in the actual distance, the real world distance. So let's continue. Let's rewrite what is given. We know that what is given is 1 centimeter on the map represents 250 centimeters in the real world, the actual distance. And what else is given in problem part B is that 12.5 meters. My friends, let's quickly convert it to 1250, right, centimeters. We must make sure that we're working in the same units. We must make sure of that. So, and let's write it like this. Let's put real distance on the real distance. 1,250 centimeters is x centimeters on the map. Let me label. This is map, and this is reality. Real world, right? Reality. Now, how we have ourselves a proportion where the two ratios, are tied together like this. And I've mentioned before that out of 4 data points in a proportion, if one is unknown, such as x centimeters, we can always solve it if we know the other 3 measurements. So let's go ahead and use the butterfly method. Again, we multiply diagonally what we know and divide by the third quantity. Go ahead, let's write it out. So we would write it out as x equals to 1,250 times 1 divide by 250. Of course, we can cancel out because we know how to solve fractions. And 125 divided by 25 is 5 centimeters. So x, that means the distance on the map is x centimeters. Okay? Now, we could have set it up a different way. We could set it up bottom to top. We could have done that. So let's go ahead and we would say x to 1 centimeters is proportional to 1,250 to 250. As you see, the solution comes up to be the same because 1 is dividing by 1 is means no action whatsoever. We say 1250 divided by 250 is 125 divided by 25 is 5 centimeters. Okay, so that's the answer. The distance on the map between two lampposts is 5 centimeters. I hope you found this helpful.